Have you ever wondered why, with all our medical advancements, curing cancer remains one of the greatest challenges of our time? We've sent people to the moon, created artificial intelligence, but a universal cure for cancer still seems just out of reach. Today, we're going to dive deep into the fascinating and complex reasons why this disease is such a formidable opponent. First, let's get one thing straight. Cancer isn't just one disease. It's an umbrella term for more than 100 different diseases. Think of it like this. Saying you are treating cancer is as broad as saying you are treating an infection. A bacterial infection is treated very differently from a viral or fungal one. Similarly, lung cancer is vastly different from leukemia or melanoma. Each type of cancer originates from different cells, behaves differently, and responds to different treatments. So, a one-size-fits-all cure is simply not possible. Now, let's talk about the origin of cancer. This is where it gets really tricky. Cancer cells aren't foreign invaders like bacteria or viruses. They are our own cells that have gone rogue. They start as normal, healthy cells, but mutations in their DNA cause them to forget their original purpose. They ignore the body's signals to stop growing and dividing, becoming essentially immortal. Because they are us, our immune system often has a hard time recognizing them as a threat. It's like trying to find a traitor hiding within your own army, wearing the same uniform. The cancer cells have mastered the art of camouflage. This leads to another huge challenge: heterogeneity. This big word means that even within a single tumor, the cancer cells aren't all identical. Imagine a garden full of weeds. You might have dandelions, crabgrass, and thistles all growing together. A single tumor can be just as diverse. As a tumor grows, its cells continue to mutate and evolve. So you might have a group of cells that are sensitive to a particular chemotherapy drug, but right next to them are other cells that are completely resistant. When a patient undergoes treatment, the chemo might successfully wipe out 99% of the tumor. That sounds great, right? But that remaining 1%, the resistant supercells, can survive and then regrow, often coming back stronger and more aggressive than before. It's a classic case of survival of the fittest, happening right inside the body. This is why you sometimes hear about cancers recurring after a period of remission. The treatment didn't fail, it just couldn't eliminate every single variation of the rogue cells. Then there's the problem of metastasis, which is the spread of cancer from its original location to other parts of the body. This is what makes cancer so dangerous. A primary tumor might be manageable, even removable with surgery. But once cancer cells break away, travel through the bloodstream or lymphatic system, and set up new colonies in vital organs like the lungs, liver, or brain, the situation becomes much more complex and difficult to treat. It's like fighting a fire that has spread from one room to the entire house. You're no longer battling on a single front, but on multiple fronts simultaneously. Detecting these tiny traveling cells before they form new tumors is incredibly difficult. Think about how treatments work. We have three main pillars: surgery, radiation, and chemotherapy. Surgery is great for solid, localized tumors, but it's not an option if the cancer has spread or is in an inaccessible location. Radiation uses high-energy beams to kill cancer cells, but it can also damage surrounding healthy tissue. It's like trying to weed your garden with a flamethrower. Effective, but with a lot of collateral damage. Chemotherapy uses powerful drugs that travel throughout the body to kill fast-growing cells. This is great for targeting cancer cells, which divide rapidly. But what other cells in our body also grow fast? Hair follicles, the lining of our digestive system, and blood cells. This is why chemo often causes side effects like hair loss, nausea, and a weakened immune system. The treatment is a delicate balancing act, a dose strong enough to kill the cancer, but not so strong that it harms the patient beyond recovery. In recent years, we've seen the rise of incredible new treatments like targeted therapy and immunotherapy. Targeted therapies are drugs designed to attack specific weaknesses in cancer cells, making them more precise than traditional chemo. It's like using a sniper rifle instead of a shotgun. Immunotherapy is even more revolutionary. It doesn't attack the cancer directly. Instead, it boosts the patient's own immune system, teaching it to recognize and destroy cancer cells. It's like giving your body's own security team a new set of instructions and better weapons. These new treatments have led to amazing breakthroughs and have saved countless lives. But even they aren't a magic bullet. Cancers can develop resistance to targeted therapies, and immunotherapy doesn't work for everyone. Why? Because again, every cancer is unique, and every person's immune system is different. Another major hurdle is early detection. For many cancers, symptoms don't appear until the disease is already at an advanced stage. By the time someone feels a lump or experiences persistent pain, the cancer may have already been growing for years and possibly spread. Developing better, more reliable screening tests that can catch cancer in its earliest, most treatable stages is a huge area of research. Imagine a simple blood test that could detect the earliest signs of any cancer. That would be a game changer. Finally, we have to consider the factor of cancer stem cells. This is a relatively new and exciting area of research. The idea is that within a tumor, there's a small population of master cells, or cancer stem cells. These cells are responsible for creating all the other cancer cells in the tumor. They are highly resistant to treatment and can lie dormant for long periods. Even if you wipe out the entire bulk of a tumor, if you leave even one of these stem cells behind, it has the potential to regrow the entire tumor from scratch. It's like cutting down a weed, but leaving the root intact. So as you can see, fighting cancer is like playing a high-stakes, multi-dimensional chess game against an opponent that is constantly changing its strategy. It's a battle against our own biology, fought on a cellular level. But here's the crucial message: hard to beat does not mean impossible to beat. The progress we've made in the last few decades is nothing short of astonishing. Survival rates for many cancers have improved dramatically. Treatments are becoming more personalized, more effective, and less toxic. Researchers around the world are working tirelessly, unlocking the secrets of this disease one by one. Every day we get a little closer. The fight against cancer is a marathon, not a sprint. It requires patience, immense resources, and brilliant minds from all fields of science and medicine. While we may not have a single cure for cancer, we are building an arsenal of sophisticated weapons and strategies to fight each specific cancer, giving more and more people the chance to live long, healthy lives. The future of cancer treatment is incredibly bright, and that's a reason for all of us to have hope. Thank you so much for joining me on this deep dive. If you found this video informative, please give it a thumbs up, and don't forget to subscribe and hit that notification bell so you won't miss our next video. Stay curious and stay healthy.